Okay, so my name is Lara Heaberlin, and the topic I chose to do for my final project was how to write secure code. I chose to do this topic because it sounded like it would be fun.
Instead of just jumping into the presentation, I'm going to take a moment to give you a brief overview of what you can expect. Each of the topics listed on this slide represent a slide that we will cover during this video. So, in order that we will cover this information, we will cover availability, confidentiality, integrity, enciphering, combining everything, reasons to write secure code, the conclusions works cited, and finally, we will wrap up the presentation. You can expect each slide to last roughly 1 to 2 minutes. So let's get started. Okay, so to begin with, we are going to discuss the components of security. These are availability, confidentiality, and integrity. We are going to start with availability. Availability is the ability of a program to access another program or file. In other words, availability deals with connections between two or more programs and the success of that connection. One of the components of security. There are three components of security. Availability is just one of them. Proper usage prevents incidences such as collisions. Okay, so in order to understand why this is important, you need to understand what a collision is. A collision is when two or more programs try to use the same resource at the same time. Collisions can cause problems and lock up the system, so by properly using the security component availability, you can prevent collisions, which saves time, effort, and even money. If you want to create secure code, then it is important to remember availability, not just as a component of security, but as a key component of secure code. So to recap, availability is the ability of a program to access another program or file. It is one of the components of security. Proper usage prevents incidents, such as collisions. The second component of security is confidentiality. Confidentiality deals with permissions and access. To simplify this statement, I will say that there are different categories of people. These different categories have access to different files, and some of these files are more important than others. Not everyone should have the same permission or access to the same things. One of the core components of security. Confidentiality is a core component of security. Confidentiality has a hierarchy, and the higher tiers have access to the lower tiers, but the lower tiers cannot access the higher tiers. I read these two statements together because I think they will be easier to explain together. For the explanation, I want to draw your attention to the pyramid on the right. I created this pyramid as an explanation of the hierarchy. The hierarchy consists of 4 different tiers. The tiers are unclassified, confidential, secret, and top secret. Suppose there was a secretary named Janice, and she had confidential clearance. In this case, Janice could see the confidential documents, but she'd also have access to the unclassified documents. On the other hand, we might have someone like Bob. He has only unclassified clearance. This is because you can slide down the pyramid but not climb up it. In other words, higher tiers can have access to lower tiers, but lower tiers cannot access higher tiers. So to recap, confidentiality deals with permissions and access. It is one of the core components of security. Confidentiality has a hierarchy. The higher tiers have access to the lower tiers, but the lower tiers cannot access the higher tiers. Our aforementioned integrity can be divided into 2 separate categories. The first of these 2 categories is data integrity. Data integrity deals with the accuracy of data. To put this in slightly altered terms, the data needs to be correct and reliable. In order to ensure data integrity, restricting user input is suggested. Restricting user input can consist of various different methods. The best thing to do would be to test all the input fields and place redirects in the case the information entered into one of the fields was bad. Bad data can include data that is the wrong type, length, or invalid. The other type of integrity is origin integrity. Origin integrity relies on whether the source is reliable or not. There are a lot of things that can determine if a source is reliable or not. In order to be reliable, the source needs to have some type of credentials and they need to be reliable. Integrity is one of the core components of security. So to recap, data integrity deals with the accuracy of data. In order to ensure data integrity, restricted user input is suggested. Origin integrity relies on whether the source is reliable or not. Integrity is one of the core components of security. Okay, so the next topic that needs to be covered is enciphering or cryptography. There are two separate classifications of cryptography. The first classification is public key cryptography. Public key cryptography uses two different keys, has a private key and a public key. In order to use a public key cryptography, you need to encode with one of the keys and decode with the other. This means that if you encode with the public key, you decode with the private key. On the other hand, if you encode with the private key, you decode with the public key. The other type of cryptography that is used is known as classic key cryptography. Classic key cryptography uses one key, has a shared public key. In other words, classic key cryptography uses a single shared key. When coding, a programmer can use encryption to raise the level of security. This is largely due to the fact that the information that is being read, written, or transferred cannot be easily decoded. Because of this, it is more secure. So to recap, public key cryptography uses two different keys, has a public key and a private key. Classic key cryptography uses one key, has a shared public key. When coding, a programmer can use encryption to raise the level of security. In order to be successful in creating secure code, you need to be fully aware not just of the individual components, but of how these components can work together. A good programmer will set up the code to use all three of the aforementioned components. In order to make secure code, you need to be able to integrate availability, confidentiality, and both forms of integrity. This is because they are all essential to write secure code. In addition to these basic steps, you also need to implement enciphering. Encipher for more security. If you encipher as well as use these three components of security, then you can increase the level of security of your code. So to recap, a good programmer will set up the code to use all three of the aforementioned components. Encipher for more security. Of course, when it comes to secure code, it's important to take a moment to remember the basics of computer programming. Making the code secure is useless if the code does not work. If the code cannot run successfully, then there is no point in it being secure. Your code needs to be free from all inhibiting errors, including compiler and runtime errors. Code needs to be tested multiple times by multiple people. In addition to running your code yourself and checking for any errors, you need to get someone else to check the code as well. This is because two people can catch errors that one person would overlook, and having a fresh set of eyes on the code is also a good idea. It's also important to make sure the person who is checking the code is fully qualified to do so. Check the end result for errors as well as checking for runtime and compiler errors. Even if there is no error in the way the program runs, there is always a chance that you made a mistake with the input. It is important that you check the output, fixing it the first time, which prevents errors at a later date. Don't forget to test for fail scenarios as well as success scenarios. This means that you want to test your code to make sure that it fails when it's supposed to fail and pass when it's supposed to pass. It's a good idea to check multiple scenarios for both. Making the code secure is useless if the code does not work. Code needs to be tested multiple times by multiple people. Check the end result for errors as well as checking for runtime and compiler errors. Don't forget to test for fail scenarios as well as success scenarios. Writing secure code can require a lot of time and effort. This means that several programmers will overlook it. However, they shouldn't. Writing secure code saves time and effort in the future. Writing secure code reduces the chance of successful attacks. By creating secure code, the programmer is taking steps to prevent a variety of problems. Creating your code in a manner deemed secure saves time and effort because it makes it harder to hack. By creating secure code, programmers raise the defense of their own code and program. By creating secure code, a programmer can prevent a lot of problems not just from external attacks, but also from internal issues. In other words, by creating secure programs, you can improve your own code. This includes reducing the chance of errors occurring during compilation, runtime, or even after execution. So to recap, writing secure code saves time and effort in the future. Writing secure code reduces the chance of successful attacks. By creating secure code, the programmer has taken steps to prevent a variety of problems. Creating secure code is a time-consuming action that is well worth the time and effort. Remember the basics of secure code. In order to write secure code, you need to remember the basic components of security. These basic components include, but are not limited to, availability, confidentiality hierarchy, data integrity, origin integrity. In addition to these basics, it's a good idea to remember that you can use enciphering to boost the security of your system. There are two types of enciphering. The first type is classic key enciphering, which consists of a single key. The second type is public key enciphering, which consists of both a private and public key. Another key thing to keep in mind is that secure code is worthless if it doesn't work. If the program fails to run due to some kind of compiler error, running error, or even an error that does not directly affect the code's ability to execute, if the code does not do what it is meant to do, then it's worthless regardless of how secure you program it to be. Remember to test the code. Even if the code seems to run, there could always be problems. It's important to test the code as accurately as possible. This means that you need to test the code for errors and for improvements. So to recap, remember the basics of secure code. Secure code is worthless if it doesn't work. And remember to test the code. For the works cited portion, it is important to note that I only really used one source that would need to be mentioned. This source was the course-required textbook. The rest of the information was from experience. I've had a few internships which required that I not only wrote, but also read code, and thought the information would fit well under this topic. The pyramid image in this PowerPoint was created by me, so there was no need to credit it either. However, I will credit the slide design to Microsoft. So I'd like to end by thanking you for your time and saying thank you for taking the time to watch this PowerPoint. If you have any questions, concerns, or comments, please feel free to let me know.